Alright, math people, this is the second video for section 3.1, so this is part 2. We are on page 2 of the chapter 3 notes, and we're going to start here with theorem 3.3, the alternate exterior angles theorem. We're going to use this diagram for both of these theorems here to save a little space. And alternate exterior angles, down here you look at 1, 2, and 3. The alternate exterior angles are 1 and 3. They're alternate angles because they're they're alternate angles because they're on opposite sides of the transversal. And they are exterior angles because they are outside of lines A and B. And I understand, like we said last time, that 1 and 2 are on opposite sides of the transversal, but they're adjacent angles, so we already had a word for that. So 1 and 3 are your alternate exterior angles. And as soon as you know the lines are parallel, you can see our little arrows here to show you that A and B are parallel. As soon as you know those lines are parallel, guarantee that alternate exterior angles are congruent. So that's our word to put in the blank lines there. Congruent. And based on our little diagram there, you can say that angle 1 is congruent to angle 3. The next one here talks about same side exterior angles. Well, our same side exterior angles in this diagram are 2 and 3. Same side of the transversal, and again they're exterior because they're outside lines A and B. Now, it'd be tempting to put the word congruent there, but you can tell that angle 2 is definitely acute and angle 3 is definitely obtuse. An acute angle is never going to be equal to an obtuse angle ever. So we can't put congruent there. And it turns out the relationship between those two angles is that they are supplementary. So that's our word for there. Supplementary. So looking at our diagram, we can tell that the measure of angle 2 plus the measure of angle 3 is 180. Right. Moving on to proof here, they're asking us to prove theorem 3.3 that alternate exterior angles are equal. So we have our diagram over here, and our given stuff is going to pull from either the diagram or from the first part of the sentence. And it talks about you have a transversal and you have parallel lines. And you can also tell they're parallel because we have our arrows here for A and B. So our given is going to be the fact that they are parallel. Line A is parallel to line B. The proof always comes from the second half of the statement. We're trying to show that alternate exterior angles are equal. Well, out of 1, 2, and 3, the alternate exterior angles are 1 and 3. So we're trying to prove that angle 1 is congruent to angle 3. And for our proof here, we're going to start off as usual with the stuff that's given, because we can't use the fact that A and B are parallel until we say it down here in our proof. So we're going to put A is parallel to B, and our reason is going to be given. And we check out our numbers here. They sort of give you a clue about which angles we have to look at or focus on, because generally speaking they won't give you extra information. You can tell that 2 and 3 here are a pair of vertical angles, and one of our theorems earlier in the year said that vertical angles have to be congruent. So we know for sure that angle 2 is congruent to angle 3. Why do we know that? Because that's what it says in the vertical angles theorem. So we're going to put vertical angles theorem. Or you could have just written out the theorem and said vertical angles are congruent, because that theorem is only 4 words long. Going back to our numbered angles over here, 1 and 2 are a pair of corresponding angles, and our first postulate in this chapter said that corresponding angles are congruent whenever the lines are parallel. So we can say that for sure that angle 1 is congruent to angle 2. And our reason there, well, that came from the corresponding angles postulate. Corresponding angles postulate. And you could, of course, write out that entire postulate and say, if you have parallel lines cut by a transversal, then corresponding angles are congruent. But most people will probably just go with the title. We don't always have titles to our theorems and postulates, but when we do have titles, it's helpful to use them. Right, we're working over here and working until we get to 1 is congruent to 3, because that is like our stopping point, our finish line. 1 is congruent to 3. Well, we just showed that 2 is congruent to 3, and we just showed that 1 is congruent to 2. Well, if both of these angles are congruent to 2, then they have to be congruent to each other. So we can say that 1 is congruent to angle 3, And what we just used there is the substitution property, because we got rid of angle 2 and replaced it with something we know was equal to it. So that was the substitution property. Or you could have also used transitive property there. Whatever you like. So we start off by knowing that the A and B are parallel, and we ended up by saying, well, then alternate exterior angles have to be equal. And the fact that we used no angle measurements here whatsoever, it proves that not only does it work for this instance, but it works all the time. All right? Flipping the page. It wants us to figure out the measure of each labeled angle. So you have lines L and M, and they're parallel because we have our arrows there. They tell us that that angle right there is 110, and they want to know how big are 1, 2, 3, and 4. So we start off by saying, well, 110. 110 is a corresponding angle with angle 1, because 110 degree angle here is in the upper right, and so is angle 1. It's in the upper right of that cluster as well. So they are corresponding angles, and they have to be equal. So the measure of angle 1 has to be 110 because of corresponding angles. Well, if 1 is 110 degrees, then right across from it is angle 2. They're vertical angles. They have to be the same exact measure. So now we know that angle 2, the measure of angle 2 is 110. Well, 1 is right next to 3 here. They're adjacent to each other, and they add up to a straight line, which means they've got to be supplementary. So if you take the 180, subtract it 110 from it, you get 70 degrees. So angle 3 has to be 70 degrees. Angle 4 is the only one left, and it's vertical to that angle. So it's got to be equal to angle 3, so it's going to be 70 as well. And there's lots of different ways you could explain that, lots of different ways you could write it up, but we're just using vertical angles and corresponding angles because we happen to be talking about them more recently here. Right, so that takes care of all 4 angles. Example 5 says figure out the values of A, B, and C. So we're trying to figure out how many degrees those 3 angles are, and they tell us that L and M are parallel because we have our arrows. This angle here is 60, that one's 45. Well, first of all, you can see we have a triangle here. And the interior angles of a triangle always have to add up to 180. So if we know that one of them is 60 and the other is 45, we add them together, you get 105, and if you subtract that number from 180, that leaves you with 75 degrees for B. Now, using a little more recent information here, if you have parallel lines, and we haven't used the fact that they're parallel yet, so we're thinking about that, if these are parallel lines, you can think of this line right here as a big transversal that keeps going. Well, if that's a transversal and those are parallel, then the A and the 60 degree angle have to be alternate interior angles, which means they've got to be equal. So that means A has got to be 60 degrees. And by the exact same idea, if you have parallel lines, if you think of this over here as one big transversal, then C and 45 are going to be alternate interior angles. And so C's got to be 45 degrees. And there are a couple different ways you could have figured that out. So B is 75, A is 60, and C is 45. And one way you could check yourself, you look at A, B, and C. A, B, and C together add up to one big straight line here. So your answers for A and B and C better add up to 180. In this case they do, so we're in good shape. And we feel pretty good about our answers. Down here with the practice problem, we have a quadrilateral. Top and bottom are parallel to each other, and you have a 90 degree angle right there. It wants you to figure out the values of x and y, then figure out the measure of all the angles. So it's a practice problem here, so you're on your own. I want you to pause the video for a few seconds, figure out x and y and all the angles, and then we'll go over the answers shortly. Alright, looking at our answers here. Here are parallel lines. You can think of this vertical line here as a transversal, which means right here we have to have a pair of same side interior angles. And same side interior angles have to be supplementary. So the 3x plus that angle, which we know has got to be 90 because of the box, have to add up to 180. They have to be supplementary. And then you go ahead and solve that. You end up with 30. We subtracted 90 from each side, and then we divided by 3. So x has got to be 30. That tells us our value of x. Now we have to go and figure out y. Well, using the parallel lines again, you think of this as a transversal going diagonally through here. Well, again, those are same side interior angles, so they're going to have to add up to 180. So the y plus the y minus 40, the first angle, plus the second angle, have to equal 180. And then we're going to combine like terms here and get 2y minus 40. Remember, y plus y is 2y, not y squared. You create y squared by taking y times y, not adding. And then we're going to add 40 to each side and divide by 2. So y is 110, x is 30. That takes care of the first part, but they also want to know how big the angles are. Well, this one's y, and we just figured that was 110. So I'm just going to go ahead and redraw this over here so we can tell what we're looking at. There's our original quadrilateral. Y has to be 110, so that goes there. We know the box always represents 90. This right here is 3 times x. Well, 3 times the 30 is going to be 90 degrees, so that's going to be another right angle. And this last one here is y minus 40. Well, y minus 40, that becomes 110 minus 40, which is 70. So that last one must be 70 degrees. And just like we could check the example 5, you can check this because this is a quadrilateral. All quadrilaterals have to add up to 360 degrees, the same way a triangle has to add up to 180. So we have 2 90s, a 110, and a 70 to add up to 360. So we're in good shape and we feel pretty good. That wraps up section 3.1, and we will talk to you next time when we're talking about proving lines parallel.